Well, all right, welcome back to another Microvellum Live session where we focus on tips, tricks, and discussions about our software, tools, and technology that help you streamline the way you work. Today we've lined up a discussion about engineering parametric products, and we've invited Tim Skolman, a longtime user and current account manager out of Canada, to help us out. So as many of you tuned in today know, you can engineer all types of products with Microvellum, from cabinetry to custom diewalls, reception areas, store fixtures. We even have customers that are engineering parametric travel trailers. I mean, the metal framing, the exterior, the interior paneling, and woodwork, and cabinetry. So the power of Toolbox certainly goes beyond standard cabinetry. And today we're going to be learning some of the basic principles of how to engineer parametric products. We're going to be working with something fairly simple, a floating shelf that uses the hover bracket system. So before we get started, I just wanted to remind you that you can ask a question at any time using our Q&A panel here in Zoom or in the comments area of our YouTube live stream. And if we don't get to your questions live, we also have a few techs helping out behind the scenes to make sure that we leave no question unanswered. So this session is being recorded and it will be available on our website at microvellum.com/live a little later this week. So without any further delay, let's get into it and turn things over to Tim. How's it going this morning, Tim?
Pretty good. How are you, Clay?
Doing well. So
Good,
what
good.
can you tell us about the hover bracket system and what led you to working on this project?
Yeah, so I was working with a customer out of BC a couple weeks ago, and they were looking to get some training on how to engineer some custom products and things. And so they have a lot of these floating shelves, as a lot of our kitchen manufacturers do, and looking for a way to mount those to the wall. And so they had come across this piece of hardware. And so this is a little bracket that they wanted to incorporate into the product. And so we thought, oh, that would make a good live event as well. So we started looking at this bracket, and if you've ever used these floating shelves, you know, sometimes they have these rods with the rail across the back, and you're using that. And if you look at the site here, I was impressed that the thing will hold up 300 pounds. I think that's 8 inches off the wall or so, but it's a pretty significant load for a floating shelf, and seems like a pretty good system. And the other thing that they wanted to put in was some LED lighting strip, and so we'll incorporate both of those. And so that's what we're going to cover today, is just how to engineer a custom product. And so as we get into it, you know, you might think, well, it's just a floating shelf. Why do we need to, you know, do any custom parametrics? I could just draw some parts in 2D and make the thing real quick. And while that's true, you could certainly do that. You could just draw some miscellaneous parts and start throwing machining on them. The benefit of this is that we're going to take about 15 minutes here and create this parametric shelf. And after that, every time you want to use a parametric shelf, it's going to come through with all the machining, all the sizing, all the part information, the hardware list, all that's going to come through for you. And so if you have, you know, 3 shelves on a kitchen, you've just saved yourself a pile of time moving forward. So a little bit of investment of time on the front end to develop something, and you can really save yourself some time in the software. And so this product is really pretty simple. It's only got, you know, a few parts, but really what we're going to go through is kind of the basics of engineering anything custom from scratch. And so as Clay said, that could be anything from, you know, a simple shelf like this to a travel trailer, toilet partitions, garage doors, you know, all sorts of things that we've seen come through the software. And so what we're going to do is just get started with something pretty simple and work with that. And so a lot of times if I'm developing something from scratch, I might start with an existing product. In this case, I'm going to start with something real simple, just a miscellaneous starter part. And so this is just an empty part, just has a size to it and has a material assigned to it. And that's all that's really involved in this part. And so at the moment, all it has is, you know, width, height, depth prompts and some miscellaneous bits about it. And so all we've got is just one part sitting here. And so what we're going to do is start to turn this into our parametric shelf. And so you can work inside of the part properties or inside of the spreadsheet, whatever you're more comfortable with. I'm going to start off in the spreadsheet to throw some prompts in quick, and then I'll flip over to the part properties, and you'll kind of see the back and forth between those two as we go. So I want to add a bunch of new prompts in here. So you can see this miscellaneous starter part really doesn't have any prompts, but prompts are going to allow me to, turn things on and off, enable machining, change the size, adjust all my parametric elements of this. So I'm just going to go here, insert a bunch of prompts, and I'll just start by creating a few new prompts in here. And so first thing that we're going to do is put in some prompts about the LED strip. So I'm going to put one in here for, let's say, include LED strip. And then I'll do an LED strip setback. And so that's going to be how far it's going to be from the front edge, and maybe an LED strip from the left edge, and LED strip from the right end. And that's sometimes these things run wall to wall. And so, you might have them offset one end, maybe it's open on one end. You can do all sorts of different things. And so I'm just setting up some prompts here so that I can have control over those different parameters. And so here I'll just say LED strip depth and LED strip height. And you can call these whatever you want. We're going to define them and give them a name here. So if you want to spell them wrong, you're welcome to do that. You can just add whatever you like in here. And so for these ones, for the LED strip, I'm going to have a little checkbox that turns on to turn that thing on and off. And so that's going to be a control type of 4. We have lots of documentation on the community about what those different control types are and things. And so you can see that there. And then we can have a look at our LED strip setback. So I'm working in metric in this case, and so I'm just going to say 50 mil back, maybe 50 mil from the left end and 50 mil from the right end. My strip depth, so if I flip back over to my HAFLA website here, looks like it's 18 mils wide and 11 mils tall here. So I'm going to say 18 for the depth and 11 for the height. And so that should give me what I need for my LED strip. And then I'll go and do the hover bracket. So I'll do the same thing, because sometimes you might want to use the hover bracket, maybe you don't. So I'll say hover bracket. And then same sort of thing, we'll say hover bracket from ends and hover bracket height and hover bracket depth. And we're going to actually draw these parts. They are hardware items, but we're actually going to draw them because they're going to be cut to size parts that you're going to want a cut list for, so that you can cut them to the right size on the shop floor. So we'll draw them in, and we'll give them some sizes here. So we'll make this a control type of 4, make it a checkbox. From the ends, we'll say it's maybe 38 mil. Our hover bracket height, if we flip back over to the website there, looks like 38.25 mils by 22.96. 38.25 high and 22.96. And so that'll give us our sizes there. So I think that will give us everything we need as far as prompts go. So I'm just going to delete those two. Blank rows, we always just want to have one blank row. Anything below that is going to be invisible. And so we'll just define those. And so defining it is really just giving it that name. And so saying, this is what I'm going to call it. So you can, change your spelling at the last minute or what you need to do. Now what we're going to do is add some new parts in here. And so this is going to be a 3-layer shelf. So we're going to put a spacer, and then we're going to have 2 finished parts. And obviously you could construct your shelf in lots of different ways, but I'm going to create a new prompt here for spacer material and another one for spacer thickness. And so if you look at the material selection prompts here, you can see we've got a material that's selected for this, and it's got a control type of 7. And so the control types are really how the prompts are going to show up in our interface here. And so I'll just show you that. I'm going to create these prompts, and we'll define them. And then we'll just flip over to the prompt screen so you can see exactly what we're doing from a user perspective. So this product that didn't really have any prompts before, we just threw in a whole bunch of new ones. We've got these checkboxes for include the LED strip. We've got the material selection prompts. We've got the spacer material. And what these control type 7s allow us to do is just right on the fly here, change what the material is for that spacer. And so we'll say it's a sheet stock material, and it's going to be, we'll say Baltic birch in this case. And we can fill in and adjust any of those parameters here. And so some of these, maybe we don't want to adjust the hover bracket size because we know what that is, but maybe use different LED strip sizes. And so you want to give the user the ability to go in and modify those. And so that's what you can do with the different control types that we've got there. So it looks like we've got our prompts all set here. This one here, we're going to change just so that we get our size correct. So we'll say this is spacer material. And so that's giving us our 12.7. Now for our height for this shelf, we're going to say it's material thickness times 2 plus a spacer thickness. And you should really paste those names in so that you don't spell them wrong, and we'll do that. But that's that gives us our height. So this is going to be a 50 mil or a 2-inch thick shelf. And then we'll just go over to our cut parts and start adding some new parts. And so I'm going to copy that original line and just paste in 2 new ones. And so this is going to be our shelf parts here. So we'll say this is our bottom shelf, this is our spacer, and this is our top shelf. And so for our spacer, we're going to change the material. And so because we're using a prompt, we're going to say equals and go to our names, our local variables, and we're going to say spacer material here. So that's the one we're going to use. If we just wanted to choose a material, didn't want to go through that prompt, we could just right click and say change material right there. And so that'll give us what we want. So that gives us 3 parts, and we'll just go ahead and redraw that product and see what we've got. And so it looks like we've just got 3 parts sitting stacked on top of each other. So obviously that's not what we want, but we're going to go into our part properties now and start modifying our locations for those. And so the part properties is just another way to access that same information. This one's a little more visual, and so we can see exactly what part we're selecting. So you can see when I highlight on it, it selects it and it shows it in blue there to show me where that part is. And now I'm going to go to my origin and rotation. So for this part, you can see if you're not using the latest 2020 builds for Microvellum, you might think that this looks a little different, which it does. This is in your latest versions, allows you to kind of see a little more visually what those parts look like as you're working here in the part properties. If that's something that you want to get a hold of, you can submit a support ticket on our community, and there's a update request option there, or you can talk to your account manager about that. So here for our Z origin for this part, we'll say paste name, and we're going to use the spacer. We're going to use the material thickness in this case. So we'll find our material thickness prompt. And so that one, we're just going to move up by our material thickness. Here you can see the X, Y, Z. And so we want to move this up in Z by that 1905. Now for our top shelf, we're going to change, we're going to select on this one. Now we want to change what we call our base point, and that's where we reference the part from. And so here we're going to change this from a base point of 3 to a base point of 4. And so when we select on that, you can see that you can updates the little icon there to show you that we're referencing from the top of this part now. And so in order to get that in the right spot, we're just going to go to our Z location. So we've got our Z origin, and we're going to say equals, and we'll just say paste name, and we're just going to go height for this one. And so that's going to put that part up at the height. And so now if we save and redraw, we've got something that looks like three layers of material stacked together, which is what we're looking for. So that's looking good so far. So now we can go, and what we're going to do is add a new part for our LED strip and our hover bracket profile. Now there's lots of different ways that you could create this machining. You could go into each of those parts that needs the machining, and you could modify them that way. In this case, I'm going to show you something a little bit different. We're going to use a dado token, and so we're going to actually create a part that is the LED strip and a part that is the hover bracket, and then add a dado token to each of those, and that's what's going to actually perform the machining inside of our top and bottom panels. And that's the power of Microvellum, is that there's lots of different ways that you can do things, and the associative machining really allows you to kind of link those parts together and give you exactly what you need. So for our first part here, we don't have any data on it, and so we're going to call this our LED strip. And we're going to give that a quantity, and we're going to link that to our little checkbox. And so we're going to say paste name, and we're going to say include LED strip. And so that's going to turn that on so that we get the right size in there. Now for our material, so we stop getting that error, we'll flip over here to our buyout materials. Now I already created a material. You could create a project level material if you wanted to, but I created a buyout material called Hayflow light extrusion here. And so that's the extrusion that we're using. I just created that as a material. It's going to show up on our reports and give us our details of what's included in that. And so here we go, we're gonna change our width. Now this LED strip, we're actually gonna turn it up on edge. And so the width of our part is actually gonna be the height of our LED strip here. So we've got our LED strip height, and we'll apply that formula. So that's gonna give us our 11 mil. And then for our length for this part, we're gonna paste name, and we're gonna say width, the width of our shelf, minus, and then we put in those two different prompts for the LED strip from the left end and our LED strip from the right end. And so we can grab that, paste that in, and that's going to give us our size. And you might say, why didn't you just type in 360? The beauty of this is that by using the prompts and that sort of thing, it gives us a fully parametric shelf. And so now if we change the length of our shelf, it's going to change the length of that cut part for the hardware. It's going to change the machining. Everything's going to come with that as well. And so that's going to give us our LED strip here. Now we'll flip over to our edge, and this one we're going to rotate up on edge, as I said. So we'll just give it a 90-degree rotation, and you can see that when we do that in our little view here, we can see the width is now the 11 dimension here. That's going up into the part, so that looks good. Now I want to change my base point. Right now it's at the back. I have an LED strip setback prompt, and that's how I control the location for this. And so I actually want to do that from the front. And so if I flip to my base point of 2, you can see my little red dot has moved, and that gives me a location. That's where we're going to reference from. And so now for our X origin, we're going to say paste our name here, and this one is going to be LED strip from the left end. And we'll apply formula. And then for our Y origin, we're going to say equals, and we'll go paste name, and we'll say depth. And this is actually going to be negative based on the way that I've got my product laid out. You can see my Y origin positive would be going that way, and so negative, and that's so that it'll sit off the wall and display correctly in our drawings. And so I'm going to say equals negative depth plus, and we'll use our paste name again, and LED strip setback. And so that's going to give me the location for my strip. On my Z origin, I'm going to keep that right on the bottom, so that's fine. And my size and everything, that looks good. So now on my drawing tokens, I'm just going to change this to the hardware layer, and that's just going to show it up as a piece of hardware and give me a visual for that. And so there you can see we've got our little part drawing for our LED strip, and so that looks good. And now what we'll do is we'll actually just copy that part, and we'll make another one, and that'll be our hover bracket. So I'm just going to say copy selected part, and now I'm going to go and change the parameters here. So I'm going to call this our hover bracket, and our prompt for the quantity here is going to be include the hover bracket instead. And then we can go to our width for that part, and same thing, we're going to use this part turned up on edge. So we're going to go paste name here and say hover bracket height. And on our length, this one, we're going to go here, paste name, and on our local variables, hover bracket from ends, and we'll do ×2 to do that from each end. So that'll give us our size for that part. We'll change our material here to the hover bracket material, and that should give us what we need for that. Now for our location for this one, it's going to go right up against our wall. And so we'll change this back to a base point of 1. We'll change our Y origin to 0. And we'll change our X origin to reference our other prompt as well. So I'm going to say paste name and hover bracket from ends. And so that'll give us our location for that. And so that should be good. Now, the only thing about this one is that we do need to set it up off the bottom of our shelf. It's going to be centered in the thickness of our shelf. And so I'm just going to go to my Z origin, and I'm just going to put a formula in there of the height minus our hover bracket height. And we'll put that in brackets, and we'll say divided by 2. So that's going to give us our location. And so based on how thick this shelf ends up, based on the materials we select, that's going to vary and keep that bracket sitting right in the center. So now if we save and redraw, we've got our parts sitting there where we want them. So that looks good. We've got all of our parts sitting where they need to be, but now what we want to do is add some machining so that those parts will go straight to Nest and be able to manufacture that shelf directly out of the software without any further interactions. And so to do that, we're going to go first, we'll start with our LED strip here, and we're going to go to our machine tokens. And as I said, we're going to use the dado token on this one. And so we're going to go associative dado with router. And here for our parameters, each one of those is described here. And now for an LED strip like this, we don't want the groove to come out past the end of the part. We want it to be nice and tight so that we can just insert it there, maybe clean out the corners with a chisel or something. And so our lead in, so the distance we come past the part, we're gonna say is 0. And we're gonna say the same for our lead out. We want that to be 0 as well. For our beginning depth, we could come in here and say, our local variables here, we could say LED strip height. Now, if we wanted to go extra deep to make sure it's seated, we could just add an extra mil, or and we could use something if we're switching between metric imperial. We could go M2U, and so the M2U function allows us to flip back and forth between metric and imperial, and so we could do something like that and give us our depth for that part as well. Now, when we do that, we've got this panel penetration, and so that's how far the part is going to go into the other part in order for this dado to work. And so we're going to say negative LED strip height, so that's going to be our panel penetration, so we'll get those at the same time. Now for our double pass thickness, this is how wide our groove is going to be, and so we'll go to our local variables here and say LED strip depth, and so that's going to be how wide our groove is there, so that's going to be good. And then our tool that we're going to use in order to cut that dado, I like to use a global variable for that. So just in case I change machines or something, I'm going to say default routing tool CW, and that'll give me my tool in order to do that. And so that looks good for that one. Now I just need to select an edge for this machine token, and so I can just do that here, and when I select that, I can see which edge is highlighted, and so in this case I want to use edge 2. That's the edge that's going into the part here, and so that's going to give me my dado token. And so now what we've got, if we look, we have our original part, but then if we look at our panel itself, you can see it cut a groove to receive that part as well. And so here we're going to do the same thing for our hover bracket. Now I could just copy those machine tokens from the one to the other. I'll just add a new one from scratch here in this case. Because we're going to put this, for this hover bracket, we've got the radius on the tool, so we want to make sure we come past far enough to give it some clearance. We've left some space on the end, so we can do that. And so here, we're going to give it a lead in, and so we'll say paste name, and there's a global called router lead. And so router lead is going to be how far past the end of the part that we're going to cut that. And I like to do the lead in and the lead out at the same time, since we're going to go the same distance on both. That'll be good. And now for our beginning depth, as far as how deep that's going to route, we can flip back to our origin and rotation, and we're going to use this formula because it's going to be our material thickness minus this formula here. And so that's going to be our beginning depth here. So I'll just paste that in. And that'll be how deep the actual groove is. Again, if we wanted to increase that, we could add a value in here. And for our panel penetration, we use that same formula, and we'll make sure we put it in brackets here so that we get all that. And that should be the same number as a negative, and so that's good. And here for our other tool here, for our dado tool, we'll go paste name and default routing tool, CW. And so that'll give us what we need for that. And again, we can use our select edge and say, in this case, we're going to want to put a dado on both edges, so it doesn't really matter which one we do first. So we'll say that's the first one, and if that looks good, we'll copy it, and we'll call this, so we've got dado 1, and then we've got dado 2. So we can select edge for that as well. And so when we do that, we've got our parts, and we've got our machining set up with our parameters to cut those dados in that part in order to receive our hover bracket there. And so what we didn't do on this one is put the double pass, and so it's only putting a single groove in there. It's not doing the full full width of our route. So we'll just flip back here and say hover bracket depth. And that's going to be our double pass value. And we'll make sure we do that on both of those parameters. And so now if we save and redraw, we've got our full dado showing on those parts, and that gives us what we need for that. And so now if we look at our bottom shelf, we've got a dado on one side for the LED strip and a dado on the other side to receive that hover bracket. Now, to make that look a little more realistic, I just created a 2D profile from a picture of the hover bracket. And so here, I just drew something quick in AutoCAD. So here I am going to add a token from the clipboard, and I just added a hover bracket profile token in order to put that on. And this is just a 2D section view of that hover bracket. And I can do the same thing for my LED strip. I threw one of those on there as well. And so we'll throw a molding token on to make that item. And so there we've got our LED strip. We've got our hover bracket showing on there, and we've got all the machining that we need in order to make that shelf what we need it to be. And so the beauty of this is now we've got this parametric. We can make this thing 900 long. When we put it out to a cut list, it's going to include our cut list for the LED strip at the right length. It's going to include our hover bracket for the right length. We're going to be able to purchase that and get the LED strip. We could go into lots more details on this product. We could get into building in a transformer, calculating how many watts of LED power we need in order to power this, put a strip in, put rendering in. Your possibilities of what you can build with Microvellum are really limitless. And so what we've kind of run through this morning is just the basics of how we can kind of quickly build something from scratch that really gives us the ability to create something that we can use over and over again without having to engineer that. And so now if I save this back to my library, I can use that again. And so if I go in here to my draw products and save it back to my library, I saved one previously, put a picture on it. And so now to create a shelf with an LED strip and the right size and everything just takes me a second. And so that's the benefit of having a parametric product, is that I can quickly set this up and then see benefits from developing that product and reusing it on all of my jobs. So now if I want to place that on a wall, give it different sizes, all that's going to come through, and I'm quickly able to run that out to the machine and give me my nesting information for that as well. So I'll have a look at the questions here, see if there's anything that has come in here. Clay, is there anything that you've seen that we want to address?
Nope, I think we've got all of them taken care of, all the ones that have come in. So I think that was great. Thanks a lot for joining us here, taking the time to go through those steps with us to create that fairly simple product, but definitely demonstrating the power of what we can do with Toolbox for sure. So if you want to learn more about how to engineer custom products like what Tim has showed you here this morning, let us know by participating here in our exit poll that I will launch right now. If you're not sure of how to contact your account manager, you can find their information in the Help About UI in Toolbox, and they'll be happy to help you get some training to learn how you can engineer products like what Tim has showed you here today. And also, if you want to download this product that Tim has engineered, you'll be able to find that on our community to download a little later today. So we just learned how to engineer that simple product, something that you can save back to your library as Tim showed you, something you can use over and over again. But if you're like most customers, your work is definitely not limited to these simple products. And I bet you have those simple or those special requests come in for something that's non-standard, a complex product maybe developed in another software like SolidWorks or Inventor, or maybe you're even modeling those products yourself in AutoCAD, and maybe you're possibly relying on a manual process to get those parts out to your shop floor and onto your CNC. Well, on July 29th at 4 p.m. Pacific time, we're going to be having another live session. This time we'll be joined by Tim Veal. He's a longtime user and current account manager out of New Zealand, and he's going to give us a few pointers on modeling in AutoCAD and using our solid model analyzer tools to convert those models to manufacturer-ready products. So whether you use these tools already or not, this should be a great session for you to attend. In fact, it will contrast today's event as Tim mentioned earlier in this demonstration, there are lots of different ways that you can work with products in Microvellum. And on the 29th, we'll show you, you don't always have to engineer parametric products. Sometimes you need a way to get those custom one-off products into your production environment quickly and efficiently without going through the steps that Tim showed you. And so using our solid model analyzer tools, we can help you with that. So registration for this event will be open later today, so be sure to watch your emails. Check our community site for the invitation. And speaking of our community site, if you haven't had a chance to check it out yet, we've recently made some changes. We've opened the site up to the general public. We've created new forums, and we're adding new knowledge-based article content daily to help existing users learn more about their products that they're using. Registration is free. The knowledge and the ability to connect and learn is priceless. So check it out. Go to community.microvellum.com to see what's happening and join that community today. So anyways, once again, we appreciate you taking the time to join us. Hopefully you learned something new, something that you can use to help you continue to streamline the way you work. And we'll catch you again next time here on another Microvellum Live session.